Why am I dancing? I know what you're saying. It's saying because he's nuts. Might be true, but I'm dancing because this is the last, I repeat, the last unit of the course, electrochemistry. So I am at it. What are you doing? Stop it. Stop crying, okay? Stop crying. I know you're upset. I know you're sad that this is the last, but there's no crying in chemistry, okay? Knock it off. Pull it together, people. Pull it together. Let's get going. Electrochemistry. First subtopic in electrochemistry is redox. Redox reactions. Redox. You've all heard of redox? I've got a pair on right now. I'm wearing my pair of Reeboks. Sounds like, it's funny. It is. You're going to miss the humor. Yes, you will. Admit it. Yes, you will. You'll miss it. Okay, let's get going. Redox. Write that word down, people. Write it down. Redox. 2 words in there. They're on the hiding, but they're there. Reduction and oxidation. You've heard of oxidation before. You know that iron oxidizes and forms rust. Okay? Rust never sleeps. Neil Young. Check it out. It's a good album. Oxidation. You've heard of that. You might not have heard of reduction before. I mean, but we've heard of oxidation. Things metals oxidize. Okay, well, what exactly does that mean? All right, well, we're going to find out. And actually, if you knew both of these, I wouldn't have to be teaching it right now, would I? Okay, that's what I'm here for. I'm here for you people. Here for you, and you, and yeah, even you. Yeah, even you. Okay, so what is this all about? Well, it's basically about the same thing all chemistry is about. It's about moving electrons. Electrons moving, grooving, shaking, and or baking. Right, when electrons move around, we have chemistry. And this is no different. This is about electrons moving. Some things gain electrons, some things lose electrons. It goes hand in hand. No different. Somebody's going to gain and somebody's going to lose electrons. That's what these 2 words mean. Now, this one's a gain or lose. This one gain or lose. Take a shot at it. Take a 50-50 shot. Come on, come on. What do you got? Come on, bring it. You won't guess. You won't. Oh, you did guess. Okay, well, we're going to find out if you're right. We'll find out very shortly if you are correct. All right, so oxidation, reduction. These have to do with moving electrons. Now, let's take a look at, think about an element on the periodic table. Copper. Copper, all right, copper. Copper is a metal. Okay? A copper atom doesn't have any charge. Right? Just cash, no charge. Just cash, no charge. Woo! All right, copper with no charge, elemental copper, an atom of copper, an atom, not an ion, because ions are charged. An atom of copper, no charge. It can lose electrons. That's what metals do. They lose their electrons, some more than others, and they can lose multiple electrons. That's why they have multiple charges. Copper has 2 charges, a +1 or a +2. Well, how come it gets a +1? Copper becomes the +1 if it gives off an electron. Get out of here, electron. I don't want you anymore. You're not welcome here. Okay, well, of course, chlorine's going to be, hey, over here, man. Over here. Come over here. I'll take you. I'll take you. I'll take you. Chlorine gets a negative charge. Copper gets a positive charge because it lost that electron. Losing an electron makes you more positive. Are you sure? I'm positive. I am on a roll today. Better than being on a bun. I'll stop. I'll stop, I promise. Actually, no, I won't. All right, now, so if you lose electrons, you become more positive. That's one of these. If you are, your chlorine hanging out over here, and this chlorine says, hey, you know, if you're chlorine without a charge and not an ion, you'll go, come over here. I'll take you. I'm not going to go through why. Okay, if you don't remember why, I feel very sad for you. Chlorine wants that one to get the 8 valence electrons, and it needs 1 more, so it gains, yeah, okay. So chlorine gains that electron, becomes a chlorine ion with a -1 charge. One of these is reduced, and one of these is oxidized. Now, do I have these right, or do I have to switch them? Okay, let's find out. Oxidation is when you lose electrons. So this one is about the loss of electrons. And when you lose electrons, you become more positive. your oxidation number increases. It becomes more positive. So oxidation number goes up. Copper went from copper 0, an atom of copper, to copper plus 1. That's oxidation. This is written under the right one of these two. So if you guessed that when things become more positive, they're oxidized. In other words, they lose electrons, they're oxidized. You were correct. Were you correct? Oh, I didn't think so. So what about copper plus 2? You know, that's further oxidized because it lost another electron in order to become a plus 2. So if you go from 0 to plus 1, you're oxidized. You become a plus 2, you're even more oxidized. There's more oxidation going on there. Okay. So here we have chlorine, and I did have chlorine under the right word here. It is being reduced because when you reduce, you gain electrons. You become, your number, your ion number becomes lower. So if you go from a 0, which is what chlorine was as an atom, to a -1, let's see, 0 to -1, if I don't owe anybody any money, 0 money I owe, but now I owe you $1, I'm in the hole. I'm going down in terms of my financial situation. Same thing here with oxidation. When you go from a 0 to a -1, your oxidation number is getting lower. It's because you gained electrons. So this is about gaining electrons. You gain, well, I'll put a positive. That's going to be confusing. Positive, I meant by gain. I'll write it out. Gain electrons. If you gain electrons, you become more negative. So the chlorine gained an electron, it became -1. Okay, more negative. If you gain 2 electrons, become a -2, that's further reduced. Your number further goes down. 0, -1, -2, it's going down, being reduced. This is kind of weird for some people because you have to gain to become reduced. Yeah, you have to gain electrons to become reduced, or reduction, undergo reduction. All right, you'll get used to it, people. You'll get used to it. So that's the difference. Oxidation number goes up. You'll lose electrons. That's what oxidation is. Oxidation number going up because you're losing electrons. Reduction, you're gaining electrons. Your oxidation number goes down. So when something gives away an electron, becomes oxidized, something else says, oh, I'll take it right here, come on, right here. Whew, thank you. That's becoming reduced. They go hand in hand. All right. So now that we have the terms down, we have to balance reactions, what are called redox reactions, reduction oxidation. In any equation that we've used in the course prior to this, we didn't pay attention to what was going on with these oxidation numbers of elements on the left and on the right, the reactant and the products. We didn't pay attention to what the oxidation numbers were doing. We didn't have to, but now we do. Okay, so what I'm talking about here is we're going to look at the oxidation numbers of these reactants. We're going to compare them to the oxidation numbers of the products and see if they've changed. If they've changed, they become oxidized and reduced. And they will go hand in hand. If somebody becomes oxidized, somebody's going to become reduced. Okay. And some things might not change at all. Some things don't undergo oxidation or reduction. And they just might remain the same. So nothing happened to them in terms of electrons being transferred. So let's take a look at these. We're going to balance this reaction. We've done that before, balancing reactions. Good, clean American fun. Good fun for the whole family, rated G. Yes, it is. I mean, some people like crossword puzzles. Some people like word search, whatever floats your boat. Some people like to do balancing reactions for fun. And who doesn't? Well, these are balancing reactions on steroids. No, I'm not talking about you being on steroids to balance them or me being on steroids to balance. That's not what I'm talking about. I'm talking about like these are like on steroids. In order to balance these, we have to undergo a several-step process. Otherwise, we are going to go blah, crazy. Your head will go boom because you won't be able to balance these. Well, that looks simple enough. I can balance that. Well, not only do we have to make sure that the whole thing is balanced on the left and the right, but we have to make sure, you can see that's not. This is a copy here, nitrogen here, all looking good so far. 1 and 1, 3, 2, and it looks like it'll be a piece of cake to balance. Maybe it will, but you also have to make sure that the charges on both sides are equal. We can't have more charge on the left than we do on the right or vice versa. The total amount of charge has to be balanced because these oxidation reductions, what's happening is some things are giving away electrons in the process of the reaction and some things are gaining them, and that's going to take some doing. Okay, so we're going to have to balance these. I'm going to give you a set of steps to follow. I'm not going to call them rules. I'm going to call them guidelines, because we all know how rebellious you Americans are. We don't like to be rules. No rules for me, American. All right, I'll give you some guidelines, some suggestions of how to balance this reaction. I'll put them out step by step. Follow the steps, and it ain't so bad. Remember, Mr. T and Rocky 3, you ain't so bad. All right? What you got? What you got? Okay. So, now, I've already been making like an ancient city and babbling on for over 10 minutes. So I am going to shut this video down, Introduction to Redox, and we'll start the next video with balancing that reaction, because that's going to take some time. All right? Go take a break, breather, do some jumping jacks.